Hello there class, Patrick here with you from St. Mary's, and today I'm here to talk to you about debugging. Now I know debugging for a lot of us can be very frustrating. I know for myself I spend sometimes more time trying to find the problem than actually programming. So what we're going to go over right now are just the two types of errors that you can have in your code. Now the first type is called a syntax error. Now, a syntax error would be the actual lines of code that you've written and there's a problem inside of it. Now, you really have to follow the rules here because the simplest of things can make your whole program crash or not work. Now, an example of this would be just an easy semicolon here. Now, I mean, really, most of the time, a semicolon really goes unnoticeable to us. I mean, it should be kind of habit by now that you would write it in, but there was always the time when you just would forget that and your whole program would then not work. Now let's say if I were to just delete this, one semicolon, and if I try to start to debug and actually start the program, you're going to find that there's going to be a problem here. Now we're just going to say no here, and what you're going to see is that there's an error at the bottom here. Now this is going to be your error list. Now most programs will have an actual built-in debugger, but if you're working with a program that doesn't, really trying to find these little bugs are going to be a real pest for you. Now you can see here that it said that there is a semicolon expected, and you can see actually what line it was on, what column, what project, and what file. It really gives you the kind of good coordinates and really where you can find it. So if we go to actually line 95 here, and they've underlined it here for us, there's a missing semicolon. Now, of course, that's not going to be able to work because now it's a continuous actual line. Quantity is now continuous with 4. Now that really comes into play of why we need that semicolon. So if we throw that semicolon back in, you're going to see that that error has now disappeared and we have no error. So if we actually go and play that, you're going to see that the whole program works and everything's going to work out fine. Now, some of you might notice this problem, the supermarket problem that we actually just did before. So I decided to use this one because a lot of you might be able to kind of see where your problems might have gone wrong with yours. Now, another syntax error that you can have is just mixing up one of your curly braces, missing a bracket. It's really simple like that. As I said before, it's really just following the rules here. You can't kind of go off the path here. You really have to kind of do what you've done before and follow the rules. So, example again, let's say if I were to remove this one curly brace. If I were to remove this one curly brace, you're going to see that that one whole block of code is not going to work, and you're going to see why. So, I deleted that one curly brace, so the end curly brace. And what you're going to see now is this for loop up top here. This for loop is all here. There's no end to it. Because as you can see here, this curly brace, that curly brace is connected, that curly brace is connected, that curly brace is connected. So this curly brace doesn't have an end to it. So this whole for loop is really all within these nested for loops. And it doesn't have an end there. As you can see, it just keeps going on and on. So now the second type of error that you can have in a program would be a runtime error. Now what a runtime error is actually making an illegal statement within your code. So what I'm first going to do, I'm just going to fix this one curly brace here. Get the program back up and we're going to get rid of all those errors at the bottom. So like I said before, the second error you can have is runtime error. Now this could be breaking a rule. So let's say, for instance, let's move down to a different kind of block of code here. Now what we're going to do is take a look at question 10 here. Now you can see here that I've made two variables, each integer variables, and I've set them to a number. And then in here I put them through a for loop. Now let's say if I were to change this interval, this integer, into, say, a string. Now you can already see all of these we're getting a lot of errors here, and the reason being is because the program cannot change a string into a number, if that makes sense. So let's try and run this, and you're going to be able to see that we're not going to be able to run it. And it's because of these errors at the bottom. So like I said before, you can't implicitly convert an integer into a string, or a string into an integer. That's a big problem there. That's a big no-no. And you might think that it's a very simple error, and it might just be very obvious to some. But after writing, let's say, hundreds and hundreds of code, sometimes looking for these mini errors is going to be very, very tough. You want to be sure to watch out for those. And if you don't have knowledge of how to properly debug, I mean, like I said before, you're going to be spending more time actually looking for the error than you actually do programming. So that's the big thing that we're going to go over today, how to be efficient in debugging and how to solve that problem. So I'm just going to quickly go back to here, and I'm just going to change that back into an integer. I'm going to see there that these errors should now be gone. There we go. So, a proper way to debug is by using breakpoints. Now, what a breakpoint is setting a block of code apart from others. I mean, really what it is it's basically a signal that tells the debugger to temporarily suspend your execution of your code at a certain point. Now, when the execution is suspended at a breakpoint, your program is said to be in break mode. Now, entering break mode does not stop or end the execution of your program, and of course your execution can be resumed at any time. So, what a breakpoint looks like is just a red dot. Now, how you get this red dot is what I like to call, is you like to go into this kind of gray area here. Now, I call this gray area the gutter because it's kind of in the background. So let's say if we were to set up a breakpoint. Let's set up a breakpoint right here at the beginning of this for loop. So you can see here that the breakpoint is set on this for loop. And basically what it will do is when I start to debug, all the code that is before this breakpoint right here will run. And then once it hits this line right here, it's going to stop. And this way we can do this for various points within your code, and you can kind of break down the code into many parts, and you can actually run that code so you can see if you're getting an error in this one part or in another part, so you're not kind of searching throughout hundreds of lines of code searching for a mini error. So what we're going to do is we're going to start debugging here, and you're going to be able to see how this works. So here we go. So we're just going to start that off in here. So all of this other code has been ran through now, and now we're at this one line. We're at this one for loop. And to individually go through each line of code, you can either press F11, or you can come up here and you can actually see one of these or you can press one of these buttons. Now there's different ways of actually debugging here. So you can show the next statement, so that would be similar to your F11. And, oh, sorry, the F11 button is here. And what you're going to do is you're just going to press, and each line of code is going to run. So you're going to be able to see here. So in the beginning here, r is equal to 1. And we're going to keep running this for loop until r is less than or equal to 3. And each time this for loop runs, we're going to increase r by 1 up until it equals 3. So right now r is equal to 1, and it accepts this rule and it accepts that rule. So we're going to go into the for loop. Now the for loop starts at this curly brace. Now in this actual for loop, there's a nested for loop. So it's going to actually run through this for loop, and this for loop says c is equal to 1, c must be less than or equal to 12, and each time C is finished in this for loop, it's going to go up by 1. So you can see here, if I keep going up here, going through each line of code, it's going to keep going through this one block of code, and each time you saw it finish the for loop, it came back up here, it increased C by 1, and then it will run through the for loop again. Now each time it runs through the for loop, and you can see here that there's going to be no problems. But what's cool is that you can go to this locals window and you can actually see what each variable is at that point in time. So let's go through this for loop. Now you can see here that each time the for loop goes through, this C value down here will change. Let's do that again. So we're going to go through it. Now the for loop is finished now, it's going to increase by 1. See how that changed to 6? So now the C value is actually equal to 6. And it's just going to keep going all the way through this for loop until your C is less than or equal to 12. Now that's one way of doing it. If you know that this for loop is correct, however, what you can actually do is you can step over this for loop and you can actually just move on to another point in your code and it will actually run. Now what that's good about is that if you already know that your one block of code is correct, you can just skip on right through and go looking for the error in your other parts of the program. Now what that's called is called stepping over. So let's say we're going to create another breakpoint right here. So when I start debugging, all of the code will run until here. It will stop here. And you're going to be able to see that I'll be able to just jump right there and then it will stop there. So we're going to start to debug. We're going to stop debugging. And we're going to start debugging again with these 2 new breakpoints. So, like before, we're at this one breakpoint right here. And if we already know that this for loop is correct, we're just going to skip right on over, and the way we're going to do that is step over. So if you know that this for loop is correct, we're going to step right over, and we're just going to click this button here. Now that's great that we can use step over, but there's another one called step out. Now what step out basically does is, when you're running this line of code here, say if you're tired of running through this for loop, and especially if you have large for loops, like this one that will run a nested for loop that is less than 12, and then that will go back into here. If you don't want to run that whole for loop, you don't have to. What you're going to do is press step out here, and it's actually going to end this for loop, and it's going to step out of it, and then it will actually skip it and move on over into this then next block of code. Now that's a good way of kind of being more efficient than usually just going through it without breakpoints, but if you really want to see what value is at each point in time rather than looking at your locals window here, is to actually go through the for loop, each line, and you can actually see what variable is equal to what. So we're going to go through this very quickly here, and we're going to go through, now right here you can see that we just went through the for loop, and what you can actually see is what this quantity variable is equal to. So if we click on this little plus sign here, you're going to see that what all these values are equal to. So we said obviously that C could not be 0 or R could be 0. So all these 0, 0, zeros are all going to be equal to 0. But right when we hit 1, it's going to be equal to something. 1, 1 is equal to 33, 1, 2 is equal to 54, and so on. So you can see here what value of quantity is actually equal to at each point, which is kind of nice, because once you're running through this through the whole time, you can actually pinpoint what value is equal to what, and if there was a calculation error, if there's any error done by the actual computer, or if there's done by you. So that's nice there. Now obviously if you're doing a lot of debugging because you have a lot of errors, let's say, that you can't find, breakpoints will really come into play. They're going to be real nice rather than going through each line of code, just pressing F11 and seeing what lines of code work, what lines of codes don't work. So try using breakpoints. They're going to help you out a lot. I know they help me out a lot now. And if you have any more questions, I'm sure there's lots of tutorials to find on YouTube. But for today, that's it, and we'll see you later.